What's going on, you guys? Mr. Allen here with some quadratic functions here. All right, we got 4 different quadratic functions and 6 different graphs with no scaling on them whatsoever. And what we're going to do here in this one is we're going to match each one of these quadratic functions to a potential graph or graphs, but we're only going to use the easiest key piece of information. So a quick refresher. From standard form, we get our y-intercept real easy and the way that it opens. From factored form, I get my x-intercepts real easy and also the way that it opens. Vertex form, we get our vertex real easy and the way that it opens. Obviously, we'd have to do a little bit more math to figure out which one it truly is, but we're going to just go with those basics right now with these graphs, okay? Not everything always involves all math at all times, okay? So for f of x here, it's opening down, right? So it could be this, just these two really. All right, it's got a negative y-intercept. So this has a negative y-intercept, and that has a negative y-intercept. So I'm going to say that f of x, that's a potential graph right here. Same with this one. Now, obviously, these are 2 very different ones, right? If, Jenny just shook, right? You hear the little collar? Anywho, if we were to go a little bit further, we could maybe find our vertex opposite of b over 2a, plug it back in, and see which one is the better option here. For now, for this video, we're going to say either one of those based on opening down and the negative 3y-intercept. None of the other ones are opening down, nor do they have a negative y-intercept, so good to go there. All right, g of x time. So this is factored form, which means I can get my x-intercepts easily. I'm looking for a positive 4 and a positive 5. So positive, and it's opening up. So which of these have 2 positive x-intercepts and they're opening up? This guy right here has that, g of x, and is that it? It looks like it. That's the only one. All right, so yeah, these are both negative. These are both positive, but it's opening down, unfortunately, so this one can't be it, right? These don't even have any x-intercepts, so it can't be those. And this one, although it's opening up, we got 2 negative ones here, right? And we got to set these equal to 0 and solve. So it can't be this one here. That's a good trick, though, on that one. A lot of people might pick this one because they see the negative 4, negative 5, but you got to solve, okay, for x. All right, so that's it for g of x. Now let's go over to h of x. So this one's opening down because it's negative, right? And again, I have positive x-intercepts. So opening down, positive x-intercepts. Which one would that be? Well, this one right here is opening down, and it is crossing at positive x values. So I'm going to say h of x here is another winner. That marker is not much different than that one. Sorry. All right, this one here opening down, but no, those 2 right there are both negative x-intercepts, so it can't be that one. None of the other ones are opening down. All right. How about k of x? Let's see here. So for k of x, it's vertex form, which means I'm going to get a vertex from this thing very easily, and it's opening up, right? It's positive. So negative 4, comma 2. Negative 4, 2 is my vertex. We can always jot that down over here. Negative 4, comma 2. So we remember. So let's see here. That's positive 4, possibly. Positive 2, and it's opening down. Never mind. We're not even going to look at that one. That's opening down. That's opening down. Let's focus on these 4. So we got negative 4, so shifting over 4, and then positive 2. So we got to be up. So looking like this guy here, negative 4, positive 2, that's a potential right here, k of x. This one's negative 4, but then it'd be a negative y value. This is positive, potentially 4, positive 2, but again, should have been negative 4, comma, positive 2. So that's the one right there. So these 2 we didn't even end up using. This one had 2 possibilities here. That's pretty dope, right? F of x showed up in 2 of these graphs. So pending the information that we were given here, again, this one we just wanted to go with our easy key information. We'd have to differentiate between these 2 for f of x because clearly it can't be both of those. They're in totally different spots there. But based on the y-intercept, the way it opens, either one could have been the case here. So there we go. That's a pretty dope problem there. It's pretty awesome, fantastic, and wonderful.